and then we'll see the Newton-Raphson method, right? Now, for the purpose of explanation, right? So what we will do, that we'll consider a 4-bus system. Let me tell you once again, bus and node it is same, right? If you go to the substation and if you ask any technical person or engineer, they will show you the bus bar, right? Where transmission lines high tension coming, getting connected, and from there output is taken also, right? But anyway, it is nothing but a node, right? That should be always in your mind. So there are 4-bus power system. In this bus, you assume this is bus 1, one generator is there, 2 it is generator is there. But generally in it here, what happened here, transformers are not shown directly. Generator connected to the bus, generator connected to the bus, but in between generator and bus the transformer will be there, that is step up transformer. Later I'll teach transformer after completing the load flow, because if I put transformer here, if I put transformer here, then things will be complicated. So any book you take, they do not put transformer, but a transformer in a transmission line, it can be modeled as a pi model. The way you have seen the pi network for transmission line, here also you can see that 2 shunt element and 1 series element, that will be seen later, right? And everywhere load is there. Load means some industrial load, commercial load, so many things are there. So everywhere this arrow indicates these are the load, right? And these are the generator, and these are the line 1, 2, 3, 4. In this case, this is a 4-bus problem. In this case, bus 1 you assume a slack bus. Slack bus means here voltage magnitude and phase angle, these two quantities are known. But in this case, how much power is coming from this generator, it is unknown. That will be done after the your what you call, after the load flow studies, because this bus will take care of the losses in the system. So in any power system, whenever you solve such thing, you have to assume that one bus is a slack bus, and that where voltage magnitude and phase angle are known. With respect to that voltage, other network voltage will come, right? Generally in per unit, this voltage will be 1 per unit and angle will be 0, right? Other buses, you have to voltage magnitude, phase angles, line flows, line losses, all you have to compute when your what you call, when load flows studies will be this network problem will be solved iteratively, right? So this is load, this is generator. Before moving further, one or two things I would like to explain. Suppose this is a bus bar. Suppose this is a bus bar. Say this bus bar is a ith bus bar, right? Suppose you have a generator here. You have a generator. Sorry, actually pressing the tab. That's why, right? Suppose this is a generator here, right? And power here is injected, because generator will supply power plus JQGI, right? Suppose here load is also there. Load is there. Say this load is PLI plus JQLI, right? This is the load. Now, if you take the net injected power, suppose this is I bus, so this PGI is injecting and load is consuming power. So I'm just making by arrow. So here it should be basically PGI minus PLI. This is for real power, and J for reactive power, it will be QGI minus QLI, because you are taking in this direction, power is being injected and load consumed, so net is PGI minus PLI in this direction. Similarly for QGI minus QLI. So if you take other direction, so it should have been PLI minus PGI, then QLI minus QGI. This is the net power injection for any bus, right? So this is PGI minus PLI, and this is JQGI minus QLI, right? Because this power is being injected. Now, when you take the bus 1 as a slack bus, that is S is equal to say 1, and total number of bus is 4, so N is equal to 4. Therefore, this equation here, N is equal to 4, right? And bus 1 is a slack bus where voltage magnitude and phase angles are known. So you have to write equation for voltage for bus 2, bus 3 and bus 4, but not for 1, because this voltage magnitude and phase angle of bus 1 is specified, right? Therefore, you can write this using the same equation. You can write when it is I is equal to 2, so it will be V2 is equal to 1 upon Y22, because bus 1 is a slack bus. It is given I is equal to 1, 2, 3, 4, but I naught is equal to S and I naught is equal to 1. That is slack bus. That's why I naught is equal to 1, because S is equal to 1, right? So V2 is equal to 1 upon Y22. Here P2 minus JQ2 upon V2 conjugate minus K naught is equal to I, because I is equal to 2. So K naught is equal to 2, but K is equal to 1 to 4. I is equal to 2, so Y2K Vk. Now K is equal to 2 to 4, you expand, but you should not consider K is equal to 2, because K naught is equal to 2. So if you do so, equation will be V2 is equal to 1 upon y22 p2 minus jq2 upon v2 conjugate minus y21 v1 minus y23 v3 minus y24 v4. Similarly, when I is equal to 3, v3 will be 1 upon y33 p3 minus jq3 upon v3 conjugate minus y31 v1 minus y32 v2 minus y34 v4. Similarly, for v4 is equal to 1 upon y44 p4 minus jq4 upon v4 conjugate minus y41 v1 minus y42 v2 minus y43 v3. Right now, Gauss seidel is an iterative method. Right, therefore the current iteration value will be, look how it is made. Current iteration value, say p is equal to iteration count. Right, so when p is equal to 0 means the very first iteration, that is initial thing. So v2p plus 1 is equal to y22 is a constant matrix. It will not change for any, it will remain constant. It will not change, right? Because it is based on resistance and reactance of the transmission line. So y upon y22, p2 and q2 also will not change for when all buses are pq buses. So in pv buses I'll show you. So p2 minus jq2 upon v2p conjugate, because every iteration, this is p means pth iteration, every iteration that v2 will change, right? So y matrix will not change, minus y21 v1 also will not change in every iteration, because v1 is fixed. This v1, the slack bus, that is your slack bus voltage, v1 is fixed. If I make v1 phasor is equal to v1 angle delta 1, that is nothing but 1 angle 0 degree. Generally we consider the voltage magnitude v1 is 1.0 and delta 1 is equal to 0. So this voltage is fixed, so iteratively this value will not change, right? Therefore this v1, no need to put p because it is constant. Slack bus voltage, it is specified. Then minus y32 v2p plus 1, because this voltage immediately it is calculated. Immediately after that you substitute, that convergence will be faster. If you make only v2p, it will converge, but it will take more number of iteration, right? Because whatever values you got before computing v3, whatever you got, you put this v2p plus 1 instead of your v2. But v3 but y34 v4 will be there because v4 was not computed. Similarly, v4p plus 1 will be 1 upon y44 p4 minus jq4 upon v4p conjugate minus y41 v1 minus y42 v2p plus 1, because v2p plus 1 is computed here. Similarly, v3p plus 1 already computed here, so you put it here, right, instead of v3p, such that solution will be converging faster, right? It will take less number of iterations, right? So whatever values previously computed, you put the values in the next equation, right? So this way, this v2 v3 v4, these three equations are there for this 4 bus problem, right? So generally I told you initial starting values 1 plus j0, that is magnitude is 1, angle is 0, right? Generally we do so. And after that, whatever data will be given, I'll show you how to compute this. Accordingly, you have to solve this problem. Now, another thing is calculation of injected power, right? That is whatever power is injected at any bus. So we know from equation 11, if you come to equation 11, this equation 11, you come from this equation 11, right? From this equation, if you look into this, pi minus jqi upon vi conjugate is equal to yii vi plus k is equal to 1 to n yik vk, but k not is equal to I, right? Then you can write pi minus jqi is equal to cross multiply. So vi conjugate into in bracket this term, right? Now you put yii is equal to magnitude yii angle theta ii, yik is magnitude yik theta ik, and vi is equal to magnitude vi angle delta I. So therefore vi conjugate will be magnitude vi angle minus delta I, and vk will be magnitude vk delta k. Substitute everything here, all these things you substitute, right? If you do so, you will get pi minus jqi is equal to magnitude vi square, then magnitude yii angle theta ii plus k is equal to 1 to n, but k not is equal to I, magnitude yik, magnitude vik vi, magnitude vk angle theta ik plus delta k minus delta I, right? So you do so. Then what you do, you have to expand this, right? Separate, you have to separate real and imaginary part. So this one is your cosine theta I plus j sine theta I, that's why these two term, and this one also cosine of this one plus j sine of this one. Therefore you can write that your what you call, this is cosine of this and sine of this, right? Then you separate real and imaginary part. if you separate real and imaginary part, pi should be is equal to this one, but this ith term is out. So when you are putting this ith term inside this sigma, then k is not is equal to I should not be there, right? So pi is equal to k is equal to 1 to n magnitude vi, magnitude vk, magnitude yik, cosine theta ik minus delta I plus delta k. And similarly, minus qi is equal to vi square yi sine theta I plus this term, but k not is equal to I, but this I term is out from this sigma. You put here, you bring this term inside that, and minus sign is here. Therefore, qi is equal to minus of this, then k is equal to 1 to n vi, vk, yk, all magnitude sine of theta ik minus delta I plus delta k, right? So this is power injected at any bus. That means the general equation is, suppose a bus bar is there, suppose this is your ith bus, so whatever it is, this is your power injection, right? So whatever expression you have got, py and qi, right? This is the power injection, that is power injected at a particular bus bar, right? So this is your pi and qi. Now consideration of PV bus. Now whenever you have a bus bar, suppose, just hold on. Whenever you have a bus bar, right? So suppose a bus is a, sometimes we get PV bus, right? It's right like this, but voltage is V magnitude, right? We write PV bus. So that means in this bus, that power injection is known, P is known, right? And voltage magnitude is known. That means your voltage magnitude, it will be specified. For example, say V is equal to specified 0.98 per unit. So this is specified, but what is unknown? The unknown quantity will be Q and delta, right? If it is a ith bus, then it will be Pi, it will be Vi, it will be Vi, it will be Pi, and Qi and delta I. These two quantities are unknown. So in this case, voltage magnitudes are specified, right? And you have to try to maintain the voltage magnitude. But let me tell you, in real power system, it's really difficult to maintain the voltage magnitude, right? But putting some reactive devices there, we try to maintain the voltage magnitude at the bus, right? So voltage P is known, voltage magnitude is known, but voltage angle is unknown and reactive power injection is unknown. That is called PV bus. So how to handle your what you call this PV bus for a load flow studies? Now generally the real and reactive power are known, and any your what you call for PQ bus, that means real and reactive power known means numericals are there later. For example, suppose in a bus bar, suppose this is your generator, right? Suppose this power, suppose I'm just putting it in terms of megawatt, say 50 megawatt plus J, say 40, this is your megavar. This is power injected by the generator. Suppose you have a load here, right? Suppose load is 20 megawatt plus J, say 10 megavar. Total, if you combine, put in bracket, then it will be MVA, right? So now net power injected, then what is net power injected at this bus? So this is your 50 megawatt injected, load is this thing. So net real power will be 30 megawatt, right? And what will be the reactive power? 40 minus 10. So 30 megawatt, right? So this is the net power injection. And that is actually, whenever we are writing it, suppose this is ith bus, that means Pi, we are writing scheduled, right? That is known. This is your Pi scheduled. Similarly, Qi, it is also is equal to here 30 megawatt, right? So in this case, it is 30 megawatt, and in this case it is 30 megawatt, right? This is actually known. That is scheduled power, right? So that's why this is the power injection, and that's why this is we are writing Pi scheduled and Qi scheduled, right? Unknown. Starting with initial values, because whenever you start any iterative process, any numerical methods, you have to start with some initial values, right? Because without that you cannot solve. From that initial values, your solution will move towards the convergence. Now in this case, what will happen, the starting with initial values of the voltage, set of voltage equation can be solved iteratively. For the voltage control bus, that is your PV bus, right? This is known for a particular bus, because PV bus and this voltage magnitude are known, but these two are specified, right? But q is unspecified. The from equation 16, I mean from this equation, you can write qi p plus 1, because you have to, what you have to do is that you have to, your this q you have to compute iteratively. So qi p plus 1 will be, this formula is there. We can write minus k is equal to 1 vi p iteration vk p iteration yik sin theta ik, but every iteration delta will change, theta will not change, it is angle of admittance, right? Minus delta ip plus delta kp, right? So now this you have to compute. First thing, this you have to compute, right? Now the set of voltage, one example when I'll give, at that time everything will be clear. The set of voltage equations are solved. However, PV buses, VI magnitude is specified, only the imaginary part of VI P plus 1 retained, right? That means what happened actually, this is actually what happened when you, I'll show you when take the numericals, that voltage magnitude, this is VI, I'm writing in the book magnitude, say VI is specified. This is actually a known quantity, right? A known quantity. VI magnitude is known, but generally when you compute, but angle is not known. So when you make your VI, we can write real part EI plus J, sorry, J imaginary part. So two parts are there, real part and imaginary part, two parts are there. VI is equal to magnitude. Therefore, your, if you take magnitude VI, it will be root over EI square plus FI square, right? Here I am writing. That means my VI square is equal to EI square plus FI square, right? This is magnitude square is equal to EI, because voltage has two parts, one real part, one imaginary, E and F, right? Therefore, and its magnitude is root over EI square plus FI square for ith bus. Therefore, voltage magnitude VI square will be EI square plus FI square. But this VI square we cannot change because it is specified for PV bus. This VI will be also VI cannot change. Therefore, this part will remain constant. Then how we will do this? What we will do it? We will write at ith iteration, this part will remain unchanged, right? But we write EIP, whatever value you get iteratively, that is different, right? After that, what we will do, that in that this equation we write at p plus 1 iteration, EI p plus 1 square, FI p plus 1 square is equal to magnitude VI square. What we will do, at every iteration, we will retain that. This is a question to you. Later, you find out the answer. What we will do in the class also, on the blackboard when I used to teach, I used to tell many things, that whenever you try to solve such kind of problem, one numerical I'll show you, it is solved here. At that time, everything will be transparent to you. What we will do, that this voltage magnitude is specified, but when you are iteratingly you are getting it, whatever value is getting, that is not correct, because you have to maintain this voltage magnitude. So what you will do, you write this one square plus this one square is equal to VI square. What we will do, we will retain imaginary part of this, whatever you have got, that will retain, but this one will compute. Therefore, EIP plus 1 is equal to VIP plus square minus this one. So this will be this much. I mean, through iterative solution, whatever you get, that EI will not take, right? Whatever that is compensating value, that will not take. We try to maintain this one. Therefore, the new value of the take, but from iterative process, this imaginary part will be retained, right? Therefore, we write EIP plus 1 is equal to this much. Therefore, EI1 real part of VIP plus 1 and FIP plus 1 is imaginary part of VIP plus 1. This one example when I will take, you make everything clear. Whatever open book and this, that, right? But when I checking the answer script, some of your answer scripts are identical. I have checked it. Handwritten may be different, but same word, if you know, photographic memory cannot be there. Right, when you write of your own, English word, English sentence will change, even equations will change. But I have seen it, right? But anyway, it is online. But I have seen it very carefully, right? So that's why marks deducted, not given this thing. So some mark deducted because all are same, certain things. But I have seen some answer script that totally different than many others, totally different. Maybe they have tried, some of them tried of their own, totally different. Right. Anyway, most of you have got good marks. Marks later I'll tell you. After third test, I'll tell you all. Third test, assignment submission. Then I'll give you some special assignment. Only one I have given. All I'll get back to you. Don't worry. I'll get back to you. I'll check. I have a lot of academic activities here. All because of online. No, all the time sitting in front of computer. You people are young. I understand you are attending so many classes, online labs. I understand everything. But for our case also, I'm an old man, right? So all the time, not only your academics, many other activities are there, right? Research scholars are there, MTech students are there. So online Google Meet with them also, right? So anyway, so whatever you have made that this is I told. Now convergence procedure, how we will do it? Convergence procedure, whatever is written here, but I am explaining such that things will be clear. Suppose you have a 4-bus problem. Bus 1 is a slack bus, so no need to consider. What you will do, take I'm just making it right. You take delta V2 is equal to V2, the voltage of current iteration, that is V2P plus 1 minus V2P, right? This is your phasor quantity. Similarly, your, say for 4-bus problem, in general I'll make it, right? This will be V3 P plus 1 minus, this is take phasor quantity, doesn't matter. Then V3, when I'm putting tilde, it is phasor quantity. Then after that, you are taking absolute. So ultimately, it will be real quantity, right? Similarly, for this one will be V4 P plus 1 minus V4P, right? In this case, this one. So delta V2, then after that, what we will do? These are ultimately, this is also phasor quantity, but you are taking absolute of this, so it will be real quantity, right? So delta V2, then what you will do? Then you take delta V max is equal to max of, in this case, delta V2, delta V3, delta V4, right? Whatever value will come, right? And if this delta V max less than equal to epsilon, then you assume solution has converged. This epsilon may be is equal to 10 to the power minus 4 or 10 to the power minus 5, because everything is a per unit. So 10 to the power minus 4, if it is less than that, that means if max is less than that, naturally all voltages difference magnitude will be less than that, right? This is one thing. And another thing is, this is one convergence criteria. So I that is whatever is written here, right? This is, that's I told you, this whatever is written here. So this is for n number of buses, but in general, similarly for pi calculated and pi scheduled. That means another thing is suppose it is start from 2 delta P2. It is given P2 calculated. I'm making it short, minus P2 this thing, right? What is happening actually? Similarly for delta Q2 also, right? Q2 calculated minus Q2 scheduled. Similarly for, in general, delta Pn will be Pn calculated minus Pn schedule, and your delta Qn is equal to Qn calculated minus Qn schedule, right? What actually in this case? In this case, it should be, that this quantity is known. This quantity is known because that is schedule power. I told you just now that generational load of this, every bus, well, every PQ bus, P and Q both are known. Every PV bus, this P is known, right? And this P2 and Q2 calculated means this you have to calculate from the mathematical equation. Then you have to find out the difference, right? Up to this thing. So see, that means for delta P max is equal to, you have to take max of, here no, you can put absolute. By chance if it is this thing, you put absolute such that everything is your what you call positive, right? You have to take delta P2, delta P3 up to delta Pn. The max of that you have to take. Similarly for delta Q max, you have to take max of delta Q2, delta Q3 up to delta Qn, right? All this max you have to take. Now if both are less than epsilon, suppose if delta P max and delta Q max together, right? Both have to be less than equal to epsilon, then solution has converged. Right? Epsilon is small value, it may be minus 10 to the power 4 or 10 to the power minus 5, right? So then, I mean, both delta, that means meaning is delta P max also has to be less than epsilon, and delta Q max also has to be less than epsilon, then solution has converged, right? And this Pi, whatever power injection equation is there, the schedule is known, but this the other one you have to calculate from this your derivation. This Pi you have to calculate. Whatever every iteration you are getting values, all these values are known. Qi is known. You have to calculate. Then you have to find out the your what you call the difference of this. Then only solution is converged. So here it is written separately. If del P and the less than epsilon and del Q, then solution is converged. So it may be 10 to the power minus 4 or 10 to the power minus 5. This is the solution convergence criteria. This convergence criteria will be true either it is Gauss-Seidel method or Newton-Raphson method, that will be seen later, right? And acceleration factor. Suppose if you want faster this thing, faster convergence, particularly this is true for Gauss-Seidel method. So current value, the acceleration value, you take the previous value Vi, right? This will be complex quantity, right? Plus alpha into the difference of the current iteration voltage minus previous iteration voltage and alpha. Generally for a transmission line system, that alpha generally gives good result in between one, if alpha is between 1.4 and 1.6, right? For a power system problem. When I was young, at that time I wrote all this code, not only Gauss-Seidel, Newton-Raphson, many other code. I think up to age of 46, 47, I was writing code, but in Fortran, remember, right? Nowadays, though, C, C++, C sharp, right? Then Python, so many things are doing it, are there. One or two of my research scholars, they know Python also. And I do not know the Python, but they be thinking about the, present research train, another thing. They write code sometimes in Python. One or two knows, or not all, right? So question is that, but our time, all these things code I was writing of my own, right? And our time, that day I was telling those senior student, that is design course, that our time there was no C was there, but later it came. At that time, C could not handle complex number. Nowadays, everything can handle complex number. But in the case of Fortran, it used to handle complex number very nicely, right? So all this code we used to write in Fortran. First Fortran 4, then Fortran. I'm coming Fortran 77, then Fortran 95. Lot of improved version is there. But in Fortran writing code also, there are a lot of advantages, right? How to define negative, positive, zero, how to, it is basically intuition. From your intuition, you can write code if you know the things, right? If you understand the whole procedure, whole mathematics, then coding is nothing. First one has to understand that what is the coding, right? So whatever I'm teaching you a little bit, once upon a time, all these codes were written by me. So I know inside exactly what happens, right? And several things may not be there in the book, right? But many books are there. Several things may not be there in the book. But question is that if you write code of your own and just check it, then you will find many unknown things. Perhaps you will discover, right? So coding is something, right? And it is nowadays coding is must for getting good job, because you are in this thing. So one has to be, that's why I tell you should be very good in coding. C sharp, C++, C sharp. First you have to know C, then C++, then C sharp, right? Then if you know Python, Java, etc., then things will be really helpful. Along with that, if you know little bit of artificial intelligence, machine learning things, then that will add further flavor to your knowledge, right? So things are changing nowadays. So you have to learn many things. That is of your own. Nobody will teach you. Of your own, you have to learn those things, right? In any way. So, and I have seen some of the students, I have seen electrical also. I have seen many students. Their masterpiece of such kind of thing. I have seen it, right? They have learned of their own. Many things they have learned. Parallel computing also. Then one student showed me long time back that said, look how this, if you in a laptop, you find out how many processors are there. Accordingly, if one computation is independent of another computation, then parallel computing is also possible for making these things faster, right? Computation faster. So I have seen it. One student one day showed me in his laptop that how things are parallelly being computed, right? So I was very happy with that student. He was a very good student, of course, right? So consider the now computation of line flows and line losses. This also you have to little bit of understand, right? So before making this computation of line flows, right? Just I have to explain. Just for the purpose of explanation, this diagram actually is drawn like this. Basically, this shunt element actually connected to this bus I, right? Similarly, this shunt element actually connected to the bus K. If I connect this, I cannot explain in easy way. That's why it is taken out. It is not out. It is connected here only, and this is connected here only, right? So whenever bus power is going, so some power will flow through the line. That is this current. IK is the current, is that your what you call. Here we have taken IIK, we have taken, right? And here it is bus K. This is bus I. This is bus IK. So part of the current will be going through this your what you call this line IIK dash at the right, and this is your this is IIK, this is your IKI, right? It will better zoom it, you can see, and some current is going to this shunt element and some current is going to this element, right? And this voltage is K. These are all phasor quantity. This is bus I, this is K. Now one thing I will tell you before explaining this. For example, suppose you have this bus bar and you have this bus bar, right? A generator is connected here, a generator is connected here. This is bus I, this is bus K, right? So what happened that when power flows from this way to that way, before going to that I am explaining this. Suppose at this point power flow is PIK because I to K, but at this point when it is entering this along this line, power loss will be there. Same will be true for reactive power also. At this point it will be PIK minus P loss. Sorry, I am making loss here. Sorry. Here it will be PIK minus PIK loss, right? Because loss has to be subtracted, right? This is your, and if you take in this direction power K to I, then in this point it is I to K. In this point it will be PKI. So in general, PKI is equal to, because direction has changed. This is in this direction, but this is in this direction. So it will be minus of your PIK minus P P loss, your what you call, I am making loss superscript, no. So loss IK. So therefore it will be PIK plus PKI is equal to PIK loss, right? That means in this direction is PIK, in this direction is K to I, PKI. If you add these two, it will you will get the loss of the line, right? Similarly, for QIK plus QKI, it will be Q loss IK. So here you measure the power. If power flow in this direction, if you measure the power, then what will happen? Sometimes this quantity may become negative. P loss become negative because of the direction, right? Accordingly, you can find out if it is become positive, then power is flowing from I to K. If loss is being negative, actually power is flowing from 2 to 1, right? So this is the understandable. Loss negative means it is not it is I square or positive only the direct due to the direction of the power flow, but that will be the loss, right? So now here, so meaning is, if you write, I mean, if you apply KCL, so IIK, this current will be IIK dash plus IIK. I have written so many lines, actually not needed, right? IIK dash IIK 0, right? There, and this IIK dash will be is equal to, actually this is voltage VI and this is voltage Vk, Vi minus Vk, and admittance of the line is Yik. So I told you this is taken here means just for the purpose of explanation. Actually, this is shunt element is connected here like line charging admittance. Similarly, here it is connected, but for the purpose of explanation, this diagram is drawn like this. So there will be no confusion, right? So Iik dash will be equal to Vi minus Vk into Yk, and this is ground. So ground potential is 0. So IIK 0 will be, this voltage is VI. This is actually connected to the bus I, right? That's why it is VI YIK 0, right? So if you substitute all this here, you will get IIK is equal to this equation, right? Now real power fed into this bus, SIK. SIK is equal to PIK plus JQIK. So this is actually VI IIK conjugate, I told you earlier, right? Therefore, this VI IIK conjugate you substitute, but ultimately you take PIK minus JK, take conjugate on both sides. right? Therefore, Pik minus Jqik, you will get this one, right? Similarly, for this bus also follow the same philosophy that directly it is written here, plus I suggest you will do that, right? So if you do so, then you will get Pki minus Jqki is equal to this much, right? Now capital Yik is equal to minus Yik, earlier for the charging admittance we have discussed, and therefore small Yik is equal to minus of capital Yik. So substitute all, right? And your what you call, and your this is where admittance angle theta ik, voltage magnitude angle delta I, and conjugate will be minus delta I, and Yik is a shunt element, only the charging admittance, so it will be J, then magnitude of Yik 0, right? So because this is shunt element, a transmission line also you have seen that your y by 2, y by 2, y0 by 2, y0 by 2, same charging admittance. So that's why it is taken your J into Yik 0 magnitude, right? So substitute all. After substituting all, you will separate real and imaginary part, right? So if you see, then therefore Pik will be this much, right? And Qik will be this much, right? Therefore, similarly, if you this you derive of your own, if you make Pki and Qki, you will get this one. I believe there is no typographical error here. Things are everything correct, right? So this will be Pik, this will be Qi. Similarly, for this bus, if you derive, then it will be Pki is equal to this much and Qki will be this much. Just now I told you that P loss Ik will be Pik plus Pki. Just now I told you, right? So why it happens, how it happens, that also I told you just now. So if you add Pik, that means your this one plus Qik, that is this one, then sorry, your Pki, that is this one. If you add and simplify, then you will get P loss K will be 2 into Vi Vk all magnitude cos delta I minus delta K minus Vi square minus Vk square Yik cos theta ik. Now you define that capital Yik is Gik plus Jbik. The Gik we call conductance and Jbik we call susceptance, right? Therefore Gik will be magnitude Yik cos theta ik and Bik will be magnitude Yik sin theta ik, right? Therefore P loss Ik, you substitute all these here, right? Whatever it is you substitute, then what you will get, that your P loss Ik will be Gik in bracket 2 Vi Vk cos delta I minus delta K Vi square minus Vk square, right? Similarly, for Q loss Ik, you do it. If you do Q loss Ik, you will get Bik into your, this is magnitude Vi square plus magnitude Vk square minus 2 Vi Vk cosine of this, right, bracket close. Then minus, because of this charging admittance, these two term will come because it is Q loss. That is minus in bracket Vi square Yik 0, then Vk square Yik 0. Here, your what you call, this is expression for P loss Ik and this is expression for Q loss Ik. That is the power, real power loss in the line connecting bus connecting I and K, and reactive power loss line connecting bus your I and K, right? In the case of Q, the charging admittance is appearing. In the case of real power loss, nothing is appearing. This you practice. Even in open book also, it will be difficult without practice. This is, everything is there. At least practice one or twice for this derivation, right? Because in the second test, I may ask you to derive something which may not be here, right? But something I'll put in different way, that without derivation you cannot answer that, right? So you have to practice. This is a simple suggestion for you. If you do not practice, you cannot derive. And if you try to take from somebody also, if somebody make mistake, your thing also will be mistake. So you have to try. Right. The algorithm is very simple. First, you have to read all the data. All the data means resistance, reactance of this thing, initial values of the voltages have to be given, right? Angles also, initial voltage angle you have to specify, initial voltage magnitude you have to specify, the real power, reactive power load you have to specify, a real power generation, reactive power generation, everything you have to read, right? First, a data file, read everything, right? This is first thing. Second thing is, in load flow studies, you have to compute the Y matrix, right? that is Y-bus matrix, right? And after that, all these equations for Gauss-Seidel method, that all V2, V3, Vn equations, you put in a loop, all these equations will be computed, right? It is not like you have to write each and every equation in the coding. Just for I is equal to 2 to n, you have to write in general and automatically it will come, right? And after getting all these voltages, previous values minus current value of the iteration, what current value minus previous value, take magnitude, and that you have to see the max of that and whether solution has converged or not. If it is converged, it is okay. Otherwise, with this new values, you have to calculate from the beginning, right? Then you have to compute slack bus power also, because I is equal to 1, bus 1 is a slack bus. It takes care of the total losses of the system, because right, because one bus has to be flexible. Otherwise, who will take care of the losses, right? Then computation of line flows, and this way things will move, right? Iterative process, it will move. So read very well. Tomorrow there is a gap. Read very well all these theories, right? Wednesday morning I'll start explaining how to solve this iterative process in Gauss-Braid. I'll start from taking this example, and one for PQ bus. This is for PQ bus. Same example for PV bus also. I'll try. I'll explain everything how to solve this, right? But you read well, right? And then your what you call Wednesday morning, then it will be very easy for me to explain everything. But you read well all this iterative process of Gauss serial. After that, after explaining those two examples, I will come to your what you call Newton-Raphson method. Today it will take a long time. This explanation, everything I have to make it. It may take more than half an hour for one example. I will explain each and every step such that you should not face any problem in the next example. Right? Do you have any idea what I'm stopped presenting? Do you have any idea? Do you have any date for exam for the second anything in February or something? Do you have anything or this thing? Because I am planning to take the next test, I think in the first week of March. Right. And third test at the end of the March. Right. I have to see that timetable in the department. I have to see it. And it will be same as Wednesday. I'll let you know the syllabus and other thing. So read this one, because two example Wednesday, it will take more than 1 hour to explain fast, right? And each and everything I'll explain, and lot of computation will be there, because polar to rectangular, rectangular to polar, in calculator you have to make it. And every time voltage magnitude angle, or either it is in general, either it is A plus JB form, or root over A square plus B square angle, your tan inverse B by A form, right? So rectangular to polar, polar to rectangular, lot of computation will be there, complex number. And you have to your what you call, you should not make mistake, right? And that is the thing. So anyway, so thank you very much. Again, we'll meet on Wednesday morning. Do you have any question? Do you have any question? Do you have any question? No question?
So,
tell.
So once, can you repeat, when do you plan to keep the tests?
One will be in the first week of March, right? That is in the same Wednesday slot. I'll keep for one this thing. Another will be your end of March, right? And there we'll stop. At this time, 1 or 2 chapter I will not cover. I'll reduce your syllabus, and but it will take time. So one will be at the first week of March. I have to see the calendar. Perhaps first March is Tuesday, so probably 2nd March. Just check the calendar. 2nd March is Wednesday. Probably first March is a Tuesday, right? So 2nd March I'm planning every Wednesday. So this is still time is there, and I'll let you know at least 7 days, 8 days before that. I'll let you know the syllabus, right? I'll let you know the syllabus. Okay, then thank you. Many of you have got 20 out of 20. Not many means at least 5 or 6, but others I have not given 20 out of 20. 16, 17 is very common, but 10, 12 also there, because those who have got 10, 12, they didn't write anything, right? Hardly 1 or 2 attempted, and that's awesome, right? In any way, thank you very much then. Again, we'll meet on Wednesday. So I'm leaving now. Okay.